Different algorithms for VT recognition. Velen, Veriki, AVR, limb lead, Brugada algorithm, Kindwall criteria, and R-way peak time in lead 2 criteria. Velen algorithm is that if there is AV dissociation, there is VT. If there is no AV dissociation, look for QRS width. If more than 140 milliseconds, it is VT. If not like that, then look for left axis deviation. If there is left axis deviation, it is VT. If there is no left axis deviation, you will look for QRS configuration. And if QRS configuration is suggestive of VT, it is left bundle branch block or right bundle branch block. In left bundle branch block morphology, you will look for V1 and so LBB configuration QRS width more than 160 milliseconds with right axis deviation. Initial R in V1 more than 30 milliseconds. Slurring or notching of the downstroke of the S wave in V1 to V2. Beginning QRS to nadir of S wave more than 70 milliseconds in V1 and V2. Any Q wave in V6 in LBB configuration. While in the right bundle branch configuration in Valen criteria, QRS width more than 140 milliseconds with left axis, big Q, big R, big R, big R, big S, small R prime, complex in V1, as shown in the figure, R to S, RS less than 1 in V6, QS in V6 in RBB configuration. Now we'll discuss the Veriki algorithm, which shows AV dissociation. If there is any, this is VT. If there is initial big R wave in AVR, it is VT. If QRS morphology is unlike typical bundle branch block or fascicular block, it is VT. VI to VT ratio less than or equal to 1. Here depicted VI to VT ratio. If this is less than or equal to 1, this is VT on general Veriki criteria. Veriki AVR algorithm. If there is initial dominant R wave, this is VT. If this is initial small r or small q wave more than 40 milliseconds, it is VT on Veriki AVR algorithm. If there is notched downstroke of negative QRS in AVR, this is VT. If the voltage in the last 40 milliseconds is more than voltage in the first 40 milliseconds, it is VT. So the R wave peak time in lead to more than or equal to 50 milliseconds. This is R wave peak time criteria, and if this is fulfilled, this is called VT. Kind-Wall criteria for left bundle branch block. In Kind-Wall criteria, V1, V6 morphology, left bundle branch block, initial R more than 30 milliseconds, onset of R to nadir of S more than 60 milliseconds in V1 or V2, and notched downstroke in V1 or V2, and any Q wave in V6 or big Q, big S or big Q, big R in V6, and monophasic R wave and no Q wave in V6. Brugada algorithm is four-step algorithm that is absent big R, biggest complex, and any precordial lead is precordial leads all monophasic R waves or all S waves. They are positive or negative concordance in chest leads, so they are 21% sensitive and 100% specific for VT. If any big R, big S complex is in V1 to V6, check if R to S more than 100 milliseconds in one precordial lead, this is VT. If R is less than 100, check for any AV dissociation, notching of QRS at various points due to superimposed P waves, with secondary signs of AV dissociation of fusion and capture beats. This is 82% sensitive and 98% specific for VT. If no signs of AV dissociation, check for characteristic features of VT in V1 to V2 and V6. If in V1 there is dominant R wave, look for RBBB morphology with three patterns in V1 to V2 indicative of VT, that is smooth monophasic R wave, taller left Rabbitier Marriott sign, small cubic R complex in V1, and two patterns in V6 indicative of VTR, big Q big S complex with no R wave, small R big S indicative of VT if left axis deviation is present. In LBBB morphology in V1, if there is dominant S wave, then three features of VT in V1 to V2 is that initial big R is more than 30 milliseconds. There is notching or slurring of S wave called Josephson sign, RS more than 70 milliseconds. And two patterns in V6 indicative of VTR, big Q, big S complex, same as for right bundle branch block, small Q, big R complex in V6. 98% specific and sensitive, around about 97 to 98%. limb lead algorithm VT is likely if any of the following is true. There is predominantly negative QRS in 1, 2, and 3. Monophasic big R wave in AVR. Opposing QRS in the limb leads. This algorithm solely based on the QRS morphology in limb leads. Its accuracy is 88, sensitivity around about 88, specificity 91, positive predictive value 97, while negative predictive value of 70% for limb lead algorithm by Chen et al.